Hi everyone, hope you all are good. We are here for grade 9 math. We're working on the book Principles of Mathematics grade 9. We're working on chapter 8 measurement. The lessons we're going to cover from the chapter are exploring optimum volume and surface area, optimum volume and surface area. So here I am on chapter 8, that is measurement, and the lesson we're working on is exploring optimum volume and surface area. So let's just start with the lesson. When the volume or surface area of square-based prism or cylinder is given, you can determine the shape with the least surface area or greatest volume in these ways. List possible dimensions for various figures. Locate the corresponding points on the graph of surface area or volume versus one of the dimensions. Graphing a table of values will often help you to organize the relationship patterns or trends. Changing one dimensions of 3D figure will affect the surface area and volume of the figure. Let's just start with the practice questions. Oh, you don't have practice question? Optimum volume and surface area. Lesson 8.8. If you multiply one dimension of a prism or cylinder, you must divide another dimension by a proportional amount to keep the surface area or volume constant. A cube is the square-based prism with the least surface area for a given volume and a cylinder with equal height and diameter in the cylinder with the least surface area for a given volume. A cube is a square-based prism with the greatest volume for a given surface area, and a cylinder with equal height and diameter is the cylinder with the greatest volume for a given surface area. You can use tables, graphing calculator, or spreadsheet to determine the effect of varying a dimension on the volume or surface area of the prism or cylinder. When you graph a changing dimension of a prism or cylinder versus surface area or volume, the graph has one of these shapes, either U or the opposite U. The optimum value for the dimension is at either the lowest or the highest point, right? Let's just start with the practice questions. Determine the dimensions of the square-based prisms with the least possible surface area for each volume. You have to find the dimensions of the square-based prism, right? So you are given the surface area and volume, right? The first one is 25 meters square. Question number 3. So you are given the volume equals 125 meters square. You have to find the dimensions of the square based pyramid prism, right? So we know that the square based pyramid with a minimum surface area for its volume is a cube. So we will use the formula for the volume of a cube, right? So V equals 125 meters square. V equals a cube, right? That means a cube equal 125. So you can cube root both sides. That would be 5 times 5 times 5. So a equals 5, right? That means the dimension of the cube are 5 times 5 times 5, right? That is meter cube, not meter square, right? Okay, the other one is 21.952 centimeter cube. 21.952, that is the volume, right? So we can say volume equals a cube. So a cube equals 21.952. So you have to cube root both side. It would be a equals 2.8. That means the dimension would be 2.8 times 2.8 times 2.8, right? Okay, let's just start with the next question. And the next question is, sugar is sometimes packaged as cubes. Each cube of sugar must have a volume of 3.376 centimeter cube. Determine the following: the dimensions of a cube to one decimal place, the volume of 64 cubes or square of sugar to the nearest cubic centimeter, the dimension of a box in the shape of square based prism, right? Okay, let's just start. So you are given the volume, that is 3.376, right? We have to find the dimension of the cube for the a part. It would be v equals a cube, right? You are given v equals 3.376. That means the both sides are equal. A cube equals 3.376, right? Let's just cube root both side using calculator. You can use also calculator, right? So it would be 2.8. A equals, sorry, 1.8. That means that the dimensions are 1.8 times 1.8 times 1.8, right? Okay, B part is the volume of 64 cubes of sugar to the nearest cubic centimeter. You have to calculate the volume of 64 cubes of sugar. You are given the volume of 1 cube of sugar, that is 3.376. So for 64, you just have to multiply the volume by 64. That is A part. So for the B part, you have to do 64 times. That is the volume of 1 sugar cube. That would be 3.376, right? So it would be 216. That is the volume of 64 sugar cubes, right? Okay. The next part is the volume, the dimension of a box in the shape of square based prism made from the least possible amount of material that will hold 64 cubes. We need to find a square based prism with minimal surface area that has the volume of 64 cubes, right? That means the prism has to be cube. So we can use the formula for the volume of a cube to find A. That would be 216 equals A cube. That means it is 16 equals A cube, right? So when you cube root, it would be A equals 6. That means then the dimensions would be 6 times 6 times 6, right? Okay, let's just start with question number 6. Okay, question number 6 is, Pernod is making an ice sculpture with 8200 centimeter cube of ice. It will either be a prism with a square base or cylinder. Which shape will have the least surface area and what dimensions will it have? Okay, you are given the volume that is 8200 centimeter cube. Question number 6. You are given the volume equal 8200 centimeter cube, right? First of all, we are going to calculate the dimensions of the prism, right? It would be V equals S square times H, right? We have to isolate H. It would be V divided by S square equals H, right? So we need to replace the solution expression for H in the formula for finding the surface area, right? So the surface area would be area of base plus perimeter and plus, no, multiply, not plus. And then you have to multiply it with the height. So base area is 2s square plus 4s dot h, right? V over s square equals V equals 8200. It would be 2s square plus 4s. V is 8200 square, 8200 divided by s square. So s square and s got cancel out. You are left with 2s square plus, you have to multiply, it is 4. 4 times 8 is 32. 800 divided by s, right? Okay, then the next question is, okay, now you have to find the surface area, right? That means, let's suppose the length of the sides are 7, 11, 15, 19, and 23, right? You have to calculate the surface area. Okay, so if A equals 7, right? You are given A equals 7. So that means you can do H equals V over A square. That would be V is 8200 and 7 square is 49. So it would be 167.3 centimeter. That is the height, right? Then the surface area is 2s square plus 32,800 divided by s is 7, right? S is 7. 2 times 7 square plus 3,200 800 divided by 7. So when you multiply, it would be 4783.7. That is the surface area, right? Okay, let's just start with question number 9. Let's just do question number 7. Each area below is the surface area of square base prism with the greatest possible volume. Determine the side length of the base and the volume of each prism. Okay, so you are given the surface area, that is 150 meter square. Question number 7a. So let's just consider the square based prism with maximum volume is a cube, right? So the area of the cube is 6a square and the volume of the cube is a cube, right? So we use the formula for the surface area to determine the length because we are given the surface area that is 150, right? So just put up the value here. It would be you're given the value of a 50, 150 equals 6a square. So when you divide by 6, a equals 5 meter, right? So when volume equals 5, that is volume equals 5 cube, that is 125 meter cube, right? So you can calculate the same way for the rest of the values given. I am done with part A, so you can do the other one also. Let's just move on to question number 9. Determine the dimensions of a square based open top prism with a volume of 24 centimeter cube. What is the minimum surface area? So you are given the volume, right? The volume is 24 centimeter cube. Question number 9. Okay, so we know that the volume equals a cube and you are given the volume that is 24 centimeter cube, right? You have to determine the dimensions. So it would be 24 equals a cube. So the value of a is 2.88 centimeter. That means the dimension is 2.88 times 2.88 times 2.88, right? Okay. The next one is question number 11. A cylinder has a radius of 12 centimeter and a height of 29 centimeter. What are the dimensions of the square based prism with the same volume as the cylinder, right? So the volume of the cylinder is volume of the cylinder is pi r square h, right? You are given the value of h that is 29 and radius is 12, right? So just replace the radius 12 square pi and h you are given is 29. So when you evaluate the value, it will be 13119.29 centimeter cube, right? Also, the volume of the cube is a cube. So here is the volume 13119.29 equals a cube. Let's just cube root both sides, right? Then a equals 23.59 centimeter. That means the dimension of the cube is 23.59 times 23.59 times 23.59, right? Okay. Okay, let's just start with question number 12. What is the greatest volume of an open top cylinder with a surface area of 25 centimeters? So you're given the surface area that is 25 centimeter square. You have to calculate the volume, right? Open top cylinder. Okay. So we need to find a formula for the surface area, right? And volume of the cylinder. The surface area of this is 2 pi r square h plus 2 pi r h, and the volume is pi r square h, right? Okay, so we know that the cylinder with maximum volume has a given surface area has its height equal to its diameter, right? So that means h equals 2r. So it would be a equals 2r square pi plus 2r pi 2r r. Okay, so when you add it would be 6 pi r square. So that means v equals pi r square times 2r. That would be 2r cube pi. So we are given the volume is 25. So it would be 25 equals 6 pi r square. So that means r equals 1.15 centimeter. So we know that v equals 2 r is 1 and 115 cube pi. Volume equals 9.55 centimeter cube, right? Okay, the next one is question number 14. A rectangular cardboard box must be designed to package 12 cans of peas. Each can has a radius of 5 centimeter and height of 10 centimeter. Determine the dimensions of the box that would require at least amount of cardboard. If you had to ship 140 cans, would packaging 12 cans per box be the most economical use of cardboard? Okay, so first we need to find the surface area and cylinder of the bowls. Okay, so to calculate the surface area of the cylinder, the formula we use is A equals 2 pi r and r, right? The radius you are given is 5 and the height you are given is 10. Let's just replace the values. 2 pi 5, 5 plus 15. That would be 2 pi times 5. 5 plus 5 is, oh, it is 20. So you have to do 2 pi 75 centimeter square. It would be 471.238. So it is necessary to pack 12 bowls in a box. Then the smallest surface area of the box is 12 times the surface area of one ball. The surface area of one ball is 471.28, right? So it means the surface area of the box is 12 times 471.238, right? It would be 5,600 54.4 centimeter square. Okay, so to replace the original formula for calculating surface area of the cube is surface area equals 6a square. You are given the surface area, that is the surface area 5654.4 centimeter, that is 6a square. Let's just calculate the value of a. It would be a equals 30.698, right? That is the surface area of the cube, 30.7, right? Okay, we are done with the lesson. Also, we are done with the book. I think that's the last chapter from the book. Yes, the last chapter from the book. We have done with almost all the book. So, if you have any questions, you can please ask. We're working on grade 9 math. We have started with the chapter measurement, and the lesson is exploring optimum volume and surface area. Optimum volume and surface area. So, if you have any questions, you can please ask. No questions? Okay, then that's all for today. See you in the next session. Bye, everyone.